So this section is about sets. What are sets? Okay. The English word set is very similar to the mathematical term set. Basically, a set is a collection of objects. They have to be well defined. I can't say vague things like my friends who are good, my friends who are smart. I can't say that, but I have to be very specific. I can say a set of students in math 2008. I can say a set of forks in that very particular box. I can say a set of pencils on my desk. So set is a collection of objects. How do we denote sets? We can have sets of numbers, we can have sets of letters, and we denote them as follows. We use curly braces or brackets, and you have to use curly braces. And let's choose the set of first four natural numbers, 1, comma 2, comma 3, comma 4. A couple of things to remember. The order does not matter when it comes to set. It's basically the same as this. These two sets are identical. Okay, they're the same set because they contain the same elements. One more word. What is an element? An element is a member of a set. 4 is an element of this set. 3 is an element of this set. Now, we write the symbol element like this. Okay, that's how we write it. Okay, like the euro sign. But anyway, we're going to see it. So once again, we learned two words so far. A set is a collection of objects. Those individual objects are called elements. An element belongs to a set. For instance, the two sets you're seeing are identical because the order doesn't matter. One more thing, 4 is an element of the set. 3 is an element of the set. 2 is an element of the set. 1 is an element of the set. 5 is not an element of this set. Generally, we use capital letters to name sets, and we name them like this. Let's call it set A. I don't need this anymore. This is set A that has 4 elements, okay? Now, I don't have a good way of writing this symbol, okay? Element belongs to symbol. E is an element of symbol, but I'll do it by hand. So I can say easily 4 is an element of A. And we're going to write element like this. Okay? Now, this is also true. 5 is actually not an element of A. And how do we write it? We write it as follows. We write the element symbol, then put a slash over it. Okay? So 5 is not an element of A. 4 is an element of A. Right. So this is the way we name sets or describe sets. There's another way. This is one way we describe sets. It's called the roster method or the listing method. There's another way. I'm going to get rid of some of these things. They're just a distraction now. This is called the set builder ladder, the set builder notation. Okay, set builder. So what does that mean? Set C. So here they're describing it nicely. This is just a piece of a screen capture of your text from section 2.2. So basically it's saying set C is all the x's that are natural numbers. Remember, natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, goes on and on. Starts with 1. 0 is not a natural number. And they are less than x. So x has to be a natural number that's strictly smaller than s. Your options are 1, 2, 3, 4. How is it read? Set C is equal to the set of all elements x such that this vertical line is read such that x is an element of the natural numbers and x is less than 5. So the only thing you have to really pay attention to this vertical line is such that, okay? Some people put a colon, but we're going to stick to our vertical lines here because that's what the text is using. Once again, this is called set builder notation. It says set C is the set of all elements X such that X is an element of a natural, X is a natural number or element of the natural numbers, and X is less than 5. All right. Okay, we have kind of discussed that. Okay, two sets are equal if they have the same elements. Again, order doesn't matter. All right. So these two sets are equal. These two sets are equal because they have the same elements. All right. These are called equal sets. Nothing too fancy. Okay. One-to-one correspondence. Okay. One-to-one correspondence is a very important concept, and there are lots of problems that'll ask you to kind of explore this idea in the MATLAB packet. So let's take these two sets. This one, and let's call it A, and let's call this set B. And let's say this is A, B, C. Okay, these two sets have a one-to-one correspondence because things can be paired. They can be dancing partners. Okay, let's take another set, C. Okay, set C, the elements of set C is more than the elements of set A and B. So A and B do have one-to-one correspondence, but A and C don't have a one-to-one correspondence. B and C don't have a one-to-one correspondence. Another thing, if you can pair up the elements and everything is exhausted, all the elements of both sets are paired out, you said they have a one-to-one correspondence. And in this context, let's talk about one more term. It's called cardinality. Let's write it down. Cardinality. What's cardinality of a set? Cardinality of a set is simply the number of elements a set has. The cardinality of A is 3. The cardinality of B is 3. Cardinality of C is 4. So if two sets have the same cardinality, they'll have a one-to-one correspondence. Fairly basic concept. When two sets, this will confuse people a little bit, but don't let it confuse you. When two sets have a one-to-one correspondence, we call them equivalent. Okay, so set A and set B are equivalent. And how do we denote it? We denote it as follows. I hope there's a tilde somewhere right here. A tilde. This symbol, little wavy thing, is pronounced tilde, T-I-L-D-E. Two sets are equivalent if they have a one-to-one correspondence and if their cardinalities are finite and they're the same. This is how we write it. So if two sets are equivalent, they don't have to be equal. But take a look at this. Let's make another set C. Set C has elements 4, 5, 6. No, let's change it to 3, 2, 1. Now, clearly, set C and set A are same. They are equal sets, okay? But they also have a one-to-one correspondence because I can pair them up clearly, right? So if two sets are equal, they are equivalent as well. But if two sets are equivalent, they may or may not be equal. I hope you understand this idea. So there will be questions on this. If these two sets are equivalent, if these two sets are equal. Again, if two sets are equivalent, they may or may not be equal. When are two sets equivalent? When they have the same number of elements and it's finite, it's not infinite, we say they're equivalent. And two sets are equal when the elements are exactly the same and the order does not matter. Okay, important concept. Very important concept. Complement of a set. Let's say, before I talk about complement, I have to talk about universal set. What is the universal set? Universal set is the set of all the things, set that contains all the elements of all the sets we are talking about. For instance, you have to define the universal set. Let's say we are talking about VSU students. We're talking about who's graduating from which college, who has what major. We're talking about students at VSU. I can say my universe is VSU students. I'm not going to go outside that. I'm only going to confine myself to the students of VSU. If I'm talking about students from Georgia, my universal set could be defined as all the students in the state of Georgia. If I'm talking about American students, I'm talking about students from California, students from New York, students from Georgia, I will have to define my universal set as all the students in the United States of America. So universal set must be defined. So we're not going to talk about large sets. So let's say my universal set for now, I'm going to take a small set. Okay. My universal set is this. I'm only talking about these 9 one-digit numbers, 1 through 9. This is my universal set. Let's talk about that means I'm only talking about sets that involve these 9 elements. Nothing outside this I can talk about. Okay. Right. It's a small enough set. So let's say I'm talking about this set. Set A is 1, 2, 3. All right. Now, what's the complement of A? How do we write it? Okay. You can write A complement like they're writing. Okay. This is also written like this, A complement. I'm going to write the second one, do the second one, because it's easier for me to type. Now, I've seen this one too, which is very intuitive. They write it like this, comp A, complement of A. Sure. I'm going to write it like this. Okay. Must have done something funny. I'm going to write it like this. Okay. So what is the complement of A? The complement of A is everything in the universe except for the guys that are in A. Okay. So I can include 1, 2, 3, but I can include 4, 5, 6, 7, 8, 9. Okay. Once again, the complement of A is everything in the universe except for A. Sorry. Give me 1 second, guys. I can't talk it right. Okay, better. So once again, A and A complement have nothing in common. However, they together when put together, they form the universe. So let me do one more example, okay? Let's say B, set B is 1, 3, 5, 7, and 9. What's B complement? Well, B complement is going to be everything in the universe except for 1, 3, 5, 7, 8. So it's going to be 2, 4, 6, 8. If I'm not mistaken, that's it. 2, 4, 6, 8. Did I miss anything? Let me double check. No, 5, excuse me. No, 5 and 4 there together make the whole set. Now, in this context, we are going to run into a fancy term. Let me see if I can type it. Give me 1 second. All right. We have a term called the empty set. The empty set. I'm going to discuss this a little bit here. Okay. This letter is called phi. It's written as follows. Okay, 0 with a slash. It's pronounced phi, P-H-I. Now, now, what I want you to understand is why do we run into the empty set? Okay, empty set is written like I wrote it. Don't write it like this. That would be incorrect. Don't do this. I mean, you can write it. It's not going to be empty. It's going to be a set that contains one element, the letter phi, or maybe the empty set. So the empty set is written as follows. The empty set. Okay. Now what happens here is why do we need it? Well, we run into it all the time. You could ask, what is the complement of the universe? You could ask, that would be a legitimate question, right? So you could say, well, I want to know this. Well, everything in the universe that's not in the universe. I mean, you can list everything except for 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's going to be this. You can write it like this. You're good. Or you can write it like this. Your choice. We run into empty sets all the time. When we are in a classroom and we're talking about students, let's say I want to know where they were born. So in Georgia, um, I could say the students born in the state of Hawaii. Okay. The set of all students who were born in the state of Hawaii. Of course, we could get one or two. It's unlikely that we will get too many students in Georgia at VSU who were born in Hawaii. Okay. So even you could run into a classroom where you're trying to find out where they were born, and you're talking about students who were born in Nebraska. It's quite likely you're going to get that set is going to be empty. You won't have too many students who were born in Nebraska. You get the point. So we run into this concept of empty sets whenever we deal with sets. Empty set has nothing in it. Empty set has a cardinality of 0 because it has no members. It's just an empty set. And empty sets and universal sets go hand in hand, and complements and empty set also kind of are related. All right, I think we're ready to answer some questions, guys. Oh, we have one more big definition to go over. All right, this is called subset, and it's denoted like this. B is a subset of A. Okay. And what does that mean? I'll give you two examples. All right. Where you will have a case where A is a subset of A. Well, 1, 2, 3, 4. Let me keep things simple. Okay. B let's say B is this. Let me see. Yeah, okay. I will have to learn how to type in type in the empty set. Let me go back, open a document. I forgot the shortcut. So it'll be a little bit of a distraction. Okay, guys. I hope I can find it. I won't waste too much of your time. All right, guys. Let me see. One second. Sorry. Let's see. Well, unfortunately, it seems like I don't have shortcuts for subset. That's okay. I will have to write it manually, and that's okay. Let me check once again. I have all sorts of shortcuts. I have ones for intersection and union, which we will need later. So don't worry too much. So let's get back. Sorry about the distraction, guys. All right, guys. This is the symbol. I'm going to write it again. Let's see, I have any here. This is the symbol. Good. We have it right here. This is the symbol. It's read subset. In our example, B is a subset of A. And what is the definition? If B is a subset of A, written B subset A, remember B comes first and this 1 point, this is U with an I, however you want to look at it. It's like the inequality sign, but curved. Okay, but curved. All right, so B is a subset of A if every element of B is in A. So let's check. B is a subset of A because 1 is in A, 2 is in A, so B is a subset of A. And C is not a subset of A. And let's write it down. C is not a subset of A. When I say not, I have to put a little slash like that. C is not a subset of A because 5 is not an element of A. So that's how we define subset. A is always a subset of A, okay? Because 1 is in A, 2 is in A, 3 is in A, 4 is in A. Using this definition, B is always a subset of B. Why? Because A is a subset of A because every element of A is an A. Obvious. B is a subset of B because every element in B is a element in B. It kind of seems a little silly, but that's the case. All right. Now, when you have a subset that has fewer elements, you call it a proper subset, like you would expect, right? Proper subset. But A and A have the same number of elements. They're really equal sets. And when you have two equal sets, they are subsets using the definition right here, but we call them improper subsets. Improper. Nothing too fancy. Okay. A is an improper subset of A. B is a proper subset of A. Okay. Something to confuse you guys further. And not on purpose, but be careful when there is a simple, there is another symbol for proper subsets, okay? So the symbol for proper subset is, now, this symbol has two meanings. One is subset. You don't know whether it's proper or improper. The other one is improper subset. This symbol has a very specific meaning. This means proper subset. All right, guys? Now let's go ahead and do a couple of problems from your book. I have assigned problems very similar to this on Blaze on MATLAB. You can go try them. Shouldn't have a whole lot of trouble. Okay. Which of the following pairs can be placed in a one-to-one correspondence? This has 5 elements. This has 5 elements. It's a one-to-one correspondence. This has A, B, C, D, E, F, A, B, I'm counting. A, B, C, D, E, F, G, H, I, J, K, L, M. 13. I'm going to assume they're thinking it's going to follow the pattern. And this is 13. So yes, one-to-one correspondence. This is a little tricky, guys. X is a letter in the word MATHEMATICS. It does have 11 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the way it's phrased, this is the set they're talking about, guys. So be a little careful. They're talking about this set. The I. C is already there. C. I think I listed all the distinct letters. Okay, in a set, we don't repeat elements. It doesn't matter if you have two M's or three M's. It's always considered one M. Okay, so keep that straight. So this set they're talking about really has. Let me count it again. MATH, math. I think I got, oh, I missed one. I missed S. So this set is what they're really talking about. And it has 3, 3, 6, 7, 8 elements. And the second set here has 11 elements. So they don't have a one-to-one correspondence. Part C doesn't have a one-to-one correspondence. Okay? Okay, moving on. Let's do one more problem from your book. So 14 and 15 refer to the same picture. All right, this phi. All right, so let's see. Let's see how we can do it. That's fine. We don't have a good choice for the symbol of this element, but we'll play a little trick. Don't worry. Okay, let's do it here. And be a little patient, okay? I'm going to play a little trick. I think it'll look nice in the recording. I'm looking for the element symbol. Some. All right, guys. Let's take these two little pictures and bring them here. I know it's a little too big, and that's okay. If it's too big, we can make it smaller. Wonderful. All right. So is zero an element of empty set? The answer is no, because zero is an element. An empty set has no element. So I'm going to put this guy here. All right. Is this number 10 to the power 24 an element of, well, let's check. What does this say? X such that X is 2 to the power n, where n is is a natural number. Okay. The small n could be 1, 2, 3, 4, 5, 6. So I want to see if I can replace small n with a natural number and get 10 to the power 1024. Let me test. Let me see what 2 to the power 6 is 64. Let's try 2 to the power 8. Not yet. Let's try 2 to the power 10. Oh, 2 to the power 10, I get it. 1024. So 10 is a natural number. So clearly 1024 is an element of this set. Okay, guys? All right. What about this one? What about the next one? 3002. Okay. Now, if n is a natural number, so one way to do it is I'm going to do a little bit of algebra, guys, okay? I'm going to say 3n minus 1 must equal 3002. I'll solve for n. If n is a natural number, I'm okay. If n is not, then I would say, okay, I'm going to add, it won't be. I'm going to add 1 to both sides, and the other side is going to be 3. Then I'm going to divide both sides by 3. I'm going to divide both sides by 3, and clearly this is 1001. And 1001 is a natural number, and therefore I would say 3002 is an element of this set. I'm going to put an E here. All right, this one, same kind of a deal. X, if X, the answer is no, X is not an element of this set. This set is basically a bunch of numbers, right? 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So I'll go with this. Okay, guys? Now, I would like to do number 15 as well. All right? Number 15 and 14 are related. They want us to say, use the symbol subset or not subset. Now, I'm going to do the same thing with subset and not subset from my Word document, so be a little careful and patient. Well, I don't have a good symbol for not subset. I have a symbol for subset. I'll take that. It's sad that I don't have a symbol for not subset. Let me see if I have it here. Nope, I don't have a symbol for not subset, but that's okay. We're going to take care of it. Don't worry. How are we going to take care of it? Let's see. Keep it here. We're going to use this a lot. That's why I'm spending a little bit of time. All right, let's see. Insert. So give me 1 second, guys. Good enough for me. And let's bring these guys. This is read not subset. It's a little big, but we'll survive. We'll be okay. All right, guys. So let's bring these guys here. Let's bring this guy here. It slows us down a little bit, which is not necessarily a bad thing. Okay. Now, I'm going to answer the same questions, but this time I'm going to put this symbol, which means subset, and this symbol, not subset. Clearly, 0 is not a subset of empty set because it is not a set at all. It has to be a it has to be a set in order for it to be a subset. And if it doesn't have curly braces, it's not a set. 1024 is an element of this set we established, so it's certainly not a subset. Okay, I'm going to go with this. Again, same thing, 3002 is an element of this set, but certainly it's not a subset because there are no curly braces around it. And I think this is going to be all of this. I can only select the second one. I know I covered some of the text, but you get the point. Let me remove this or make it even smaller. So all the answers are the same, this one. Okay, guys, that's all I have for today. I don't know how long the class was. I hope it wasn't too long. You should be able to handle all the problems from 2.2. If you can't, you know what to do. You can always email me. I will do some of those problems. This section is they seem a little technical. We learned a lot about a few concepts and a lot of symbolisms, a lot of symbolism. We we learned how to use the element symbol, subset symbol, not subset symbol, and sets, and all those things. I'll see you next class. Bye bye.